Hi, I'm Doron Dekel, the Chief Technology Officer and Co-CEO of Claron Technology. In the next few minutes, I'd like to give you a sense of what our WIF product is all about. WIF was designed to accelerate the development of software that handles medical images. Such software typically aims to put image data within sight, that is, to visualize it, or to extract useful information from the data with insight, applying computer vision algorithms to it. To give you a sense of what WIF can do, here are some examples of WIF-based products, either already on the market or in the final stages of development. There are already more than 30 such products marketed by 13 different companies. We expect additional WIF-based products to continue reaching the market at an accelerating rate. Medical imaging applications share many functions and features with each other. It is then possible to start a new project with as much as 80% of the needed code available for reuse from a similar product, cutting the development effort by perhaps a factor of 5. Except that most companies don't have such similar product code to reuse. Not so for Claron. Through dozens of application development cycles, Claron has accumulated a large body of reusable code and packaged it in WIF. With each product added, WIF's feature set expands and its robustness improves. WIF's functions, over 10,000 of them, store, send, identify, visualize, and analyze patient anatomy in images of all types. Other than the classic standalone desktop application, WIF supports configurations where all the memory and compute-intensive operations are done on a centralized powerful server, while the users interact with the data remotely using lightweight or web browser-based clients. WIF was designed from the outset to take advantage of the best features of .NET. We provide the source code to WIF, and our customers not only step through WIF code, but also modify or extend it. The modified code is merged into subsequent releases. WIF uses a highly optimized CPU-only raycasting volume renderer. This is in contrast to other toolkits that rely on GPU gaming cards. Working with these cards has proven a major liability. In particular, models get replaced with new ones which are not fully compatible every year or two, and GPUs cannot be virtualized for cloud-based deployment. Designing a large body of software for efficient reuse is very hard. There is really no substitute for a lot of hands-on experience developing medical imaging applications. At Claron, our engineers not only have such experience, some of it going back to the early 1980s, but some of us were deeply involved in developing a similar framework, the Imaging Applications Platform, or IAP. We learned many valuable lessons from that earlier attempt, and all of these lessons were incorporated into WIF's design. While WIF is still young, we can confidently say it has been very successful in fulfilling its role and delivering on the benefits we expected of it. The number of WIF-based products continues to grow, and with it the number of engineers who use and modify it, yet WIF remains robust and fast. One of the key lessons we learned in our long experience is that complexity is the main enemy of engineer productivity. A complex framework with layers of abstraction and asynchronicity leads to long learning curve, tricky bugs, and slow execution. So we started with a structure that is simple and easy to understand and to follow, and we are religiously trying to keep it as straightforward and easy to grasp as possible. Here you see the components or assemblies of WIF. Despite the vast range of WIF's functionality, there aren't many of them, and they are logically named and hierarchically layered. Most applications need to add only one or two more assemblies on top. On the right you see an example of the assemblies involved in a complete standalone surgical navigation system. There are 9 WIF assemblies with only a single application assembly using them. To reduce costs, some customers wish to license only a subset of the functionality. To accommodate them, we split WIF into automation and visualization subsets and are offering to license them separately. For example, customers who don't need automation or have their own automated image processing modules can license only the visualization framework. To help clients get a working proof of concept program quickly, we provide the source of WIF demonstration programs. The demo programs show, for example, how to create and customize a powerful user interface, or how to segment and visualize specific anatomical regions in a large image volume. We also offer to quickly develop or help develop the first release of the product, further cutting time to market. In addition to evolving and testing the main WIF trunk daily, we prepare semi-annual releases which undergo a complete documentation and verification cycle according to the ISO 13485 standard for quality management of medical devices. With the growing WIF licensing revenue stream, Claron has both the motivation and the means to continue evolving and supporting WIF for many years to come, at least a decade, hopefully much longer. There's much more about Claron and WIF at our website. I'd be happy, of course, to hear from you via email or just pick up the phone and call me. This is my personal extension number. Thanks for your time and your interest.